Hey everyone, and welcome. Today, we're going to pull back the curtain on the secret language of computers, discrete mathematics. I know, it might sound a little intimidating, but trust me, it's really just a fascinating way of thinking that helps us solve all kinds of puzzles in our digital lives. So let's just dive right in. Okay, let's start with a question for you. Think about a simple 8-character password, using letters and numbers. How many possible combinations do you think there are? Thousands? Maybe millions? Well, the answer is actually in the quintillions. That's a number so big it's almost impossible to imagine. And you know what? Figuring that out isn't some kind of magic trick. It's a classic discrete math problem. So here's our game plan for today. First, we'll break down what discrete math actually is. Then we'll look at how it's different from the math you might be used to. After that, we'll get into why it's so incredibly important, check out some cool real-world puzzles it solves, and finally, we'll take a quick peek at the topics it covers. All right, first up, let's get right to the heart of it. What are we really talking about when we say discrete mathematics? In the simplest terms, discrete mathematics is just the study of discrete objects. That's the textbook definition. But that just leads to another more important question, right? What in the world does discrete even mean? Well, discrete just means things that are individual and separate. A great way to think about it is a staircase. You can count the steps, 1, 2, 3. Each step is a distinct unit. It's not a smooth, connected ramp. And that very idea, the idea of things being not connected, really gets at the fundamental split in the world of math, the huge difference between the discrete and the continuous. So here's the breakdown. Discrete math, on one hand, is all about things you can count, like the number of pixels on your phone's screen or the number of people in a room. But continuous math, think calculus, that deals with smooth, flowing values, things like precise measurements, time, or distance, which can be broken down infinitely. You can see this perfectly just by looking at numbers. The natural numbers we use to count, 1, 2, 3, they're discrete. There's a jump from one to the next. But then you have the real numbers, and those are continuous. Between the number 1 and the number 2, there's an infinite number of other numbers. 1.1, 1.11, 1.111, and on forever. There are no gaps at all. And if you want a perfect everyday example, just think about a clock. A digital clock is discrete. It clicks from 1057 directly to 1058. It's an instant jump. But an old school analog clock, its second hand sweeps smoothly, continuously, covering every single fractional moment in between. It's a tale of two completely different worlds. Okay, so things are either countable or they're not. But why does this actually matter? Why should you care? Well, it turns out this way of thinking isn't just a powerful tool for your brain, it's also the absolute foundation of our entire digital world. First off, on a personal level, learning discrete math basically gives your brain a workout. It trains you to think logically, to take these big, complicated problems and break them down into smaller, solvable steps. It seriously sharpens your problem-solving skills no matter what you do. But if you're into computer science, it's not just helpful, it is absolutely crucial. Computers, at their core, only understand discrete data, ones and zeros, bits and bytes. So everything from databases and computer security to the operating system running on your laptop is built directly on the principles of discrete math. It is literally the language they speak. So we get what it is, and we get why it's important. Now for the really fun stuff. Let's look at the kind of amazing real-world puzzles that discrete math lets us tackle every single day. So imagine you're a company like Google, and you need to sort a list with millions of items on it. How do you do that in the blink of an eye? The answer comes from sorting algorithms. These are super efficient, step-by-step instructions that come directly from the world of discrete math. Or think about this, when you pull up Google Maps to find the fastest route, what's it actually doing? It's seeing the world as a huge network of points connected by lines, like cities connected by roads. Finding the shortest path through that network? Yup, that's a classic discrete math problem. Now here's a famous little brain teaser. Look at this shape. Do you think you can trace the whole thing without ever lifting your pen from the paper and without going over the same line twice? This is actually a problem from a field called graph theory, and discrete math gives you the rules to figure out if it's even possible before you start drawing. And how about security? How do you send a message online and make sure only the right person can read it? Modern encryption is built on number theory, which is a huge part of discrete math. It creates these mathematical locks that are really easy to create, but almost impossible to break without the right key. So from sorting massive amounts of data to finding the fastest way home to solving puzzles and even keeping our private messages secure, the elegant, powerful answer behind all of it is discrete mathematics.
So, if this is the key to solving all those things, what does the toolkit actually look like? Let's take a quick peek under the hood at the main topics that make up this field.
So this is the whole shebang. You'd study something called combinatorics, which is basically the art of counting, and that's exactly what you'd use to solve that password problem from the beginning. You'd use graph theory to map out networks for your GPS app or to solve that pen and paper puzzle, and it all rests on a foundation of logic, which is literally the set of rules that computers use to think. Which really brings us to this perfect summary. Discrete math isn't just one thing, like algebra. It's more like a family of different mathematical fields, and they all share one single common property. They deal with things that are separate and countable. They are discrete, not continuous. So, from the way the internet is structured to the logic humming away inside a single line of code, our modern world is just built on top of a mountain of these fascinating discrete puzzles. And really, the only question left is, which one are you going to solve first? Thanks so much for watching.